Any moving thing, anything moving has energy, and that is your kinetic energy. So the movement can be in many ways, and here we have movement not only in terms of moving from left to right, but also rolling. So we are looking at a wheel which is rolling, and we are trying to figure out the kinetic energy. So we are looking at kinetic energy of a rolling wheel as measured by the stationary observer. That is, you are sitting, that's a stone, you are sitting and watching this. That's the funda. Now, if viewed for an instant of time, the rolling as pure rotational about axis via, say, a point P. So P is this, what I'm trying to tell is, if I take this point P, right, you have seen this, the blurry photo, right? Point P looks to be stationary and everything else is moving forward, rotating. So let me put it across to you guys in this manner. So we have seen this actually. So we have things rotating, right? We have things rotating. But if I shift the axis of rotation, so something like this, almost something like this. So basically we are looking at a wheel in this manner. Technically, of course, it doesn't look like that, but technically it can be viewed in this way. So here both the objects are rotating, honestly. So let me change the shape. It's actually this. Both are rotating. But when you shift the axis of rotation to the bottom, it would look something like this. Of course, this is not the shape. We have this as the shape. It would look something like this. You guys agree? So this is what we have written over here. This statement means that if viewed the rolling as pure rotation about axis via point P, if we view it, actually I can change the language. If we view the rolling as pure rotation about axis via point P, then the kinetic energy of this wheel can be seen as half IP omega square. Here, what is omega? Or let me write it this way, it's much easier to discuss. This is your angular speed, right? And this would be the rotational inertia. But rotational inertia of the wheel about, not with the center of axis, about the axis which is via point P. So that's P. So how do you find it? So I need to figure out, next step would be to figure out IP. The moment of inertia of the wheel with point P. So how do you do it? Basically this. How did I do it? I shifted the axis of rotation from the center to this. So basically I can make use of, using what? Yes, using parallel axis theorem. So what does it tell? At point P, we can view it as moment of inertia through the center of mass plus md square. Here d is equal to r, that you guys can substitute, and you end up with mr square and stuff. Okay, so that you guys can write. Now let's substitute back to 1. Say this is 1. So let's see what happens. Substituting above expression to the equation 1. So we have IP is equal to, sorry, not IP, kinetic energy is equal to, at point P is equal to half I minus, not minus, sorry, plus mr square times omega square, right? So if we expand it, we almost have the answer. So remember, we started the discussion with what? That mr square omega square. That we can view any kind of motion, any kind of rolling motion as a combination of translation and rotation. Is it not? So if I happen to substitute over here r omega as velocity of center of mass, this expression I hope you guys remember, this we have derived for pure rotation. If I substitute this, I'll end up with half this expression plus half mass times of velocity square. This expression represents what? This expression represents the kinetic energy of, correct, kinetic energy of center of mass. So this is your translational kinetic energy, and this is your rotational kinetic energy. There are many expressions actually. We can further rewrite this as many, in many forms. So I'll leave it to you guys. Whatever you want, you can end the derivation with. So there is few more steps. So we have many possible expressions. I'm not going to do that. So point for me here is to show that whatever we started discussions with, that we can segregate or discuss rolling motion as combination of translation and rotation, and that's what we are doing over here. Okay, even the energy over here can be calculated separately and added up, and we'll figure out the kinetic energy of the object, which is rolling basically. Okay, so pause, have a look, and again the final expression, whatever you guys want, because different books have different final expression, so I don't want to sit and derive that. Simple set of substitution. Please do that too. Please do that so that you end up with whatever results you guys want.